I do want to do one more thing about our 3 trips, so we're not leaving our 3 trips yet. I think this will be the last video that's all about those 3 trips. But what I want to do is I want to show you all one way of graphing these trips and determining from the graphs the average velocity. Again, this is not average speed, it's average velocity. Okay, what you remember is V average is delta x over delta t. Okay, keep your eye on this fraction here, on this expression. We'll be coming back to it. Okay, delta x, let me make that a little bit brighter for you. Because it's important. Delta x over delta t. And also remember, as we move forward, that delta x is displacement. And what does displacement depend on? Class, in unison? Delta x, the displacement, depends only, I heard you loud and clear, that was lovely, depends only on the final position and the initial position. Okay. And so does, and of course delta t is final time and initial time, but the displacement is determined only by final and initial position. So let's do a graph here. Let's make a graph of position x versus time t. And let's look at trip number 1. Okay, trip 1. Well, at time t equals 0, right down here at right here at t equals 0, where do we start? We start at position 2.1, right? So we start here, right? And that is position. That is at 2.1, and this is going to be position in miles, of course. Oops, that's a meter. Get it straight. Miles. Okay, so we're making the graphs in miles. So we start there. We start our clock, t equals 0, but we're at 2.1. Okay, and then where do we stop? Where do we stop? We stop at x equals, right, this is the first trip. We're going from your house to Publix. You're doing that. That's all you're doing. When you reach position 6.4 miles, the time is now 9 minutes. All right, so you start at that dot there, but you end at this dot. Oops, not pink. Don't want to use pink here. You end up here. A higher value of position at 6.4 miles at time 9 minutes. So that's the initial point, and that's the final point on our x versus t graph. Okay. Let's connect those with a line. So we went from here to there. We'll talk about the significance of this pink arrow in just a second, but for right now, I just want you to see that it connects your initial point with your final point on an xt plot. Okay? All right. Let's do trip 2. All points are going to start, all initial points are the same, right, at 2.1 miles. Right, this is x in miles. This is going to be t in minutes. So the starting point is the same. Right? And you go to, at some point, right, you're at 6.4 miles. You remember this trip? your house to Publix to your house. So what's going to happen is you're going to mosey up this way, right? You're going to reach Publix at some time later. We don't know what time you reach Publix or when you leave Publix, but you make it to Publix, then you turn around and you come back. And where do you end up? You go from your house to Publix back to your house. So you're going to end up at the same value of X where you started. You're going to come back down this way and arrive at Publix at 16 minutes. I'm going to erase this because it looks like 9 meters and that's wrong. Okay. So you went toward Publix, right? And then you got to Publix at 6.4 miles. Okay. Then you came back. Okay. So what's happening here is that you are ending up where you started. You increased your position as you went from your house to Publix, and then you decreased your position as you went from Publix back to your house. You're increasing up the number line, up the coordinate system here. You start at your house, you go to Publix, you turn back around and go back to your house. Now our solid pink line, arrow, connects the initial point, the final point. Okay. So now this is our initial point. This is our final point. Now notice that the X value of point I and point F are the same. They're both at 2.1. So this is a horizontal line on the graph. Okay. You start and end at the same position. Of course, it's later in time when you get back there to point F, but your position on the number line is the same. Now for trip 3. Same set of axes as before. This is going to be X in miles. This is going to be T. Is this going to fit? Yes, I think it's going to fit. T in minutes. Again, because we're starting from your house, which is at 2.1 miles, we all start here again. Every trip starts from right there at 2.1. Okay? And now you're going to go to Publix, right? You're going to go up to 6.4 again. First part of the trip looks very much the same. You're going to mosey on this way, and you're going to get to Publix at some time. We never talked about how fast you got to, with this trip, with the second 2 trips, T2 and T3, I mean trip 2 and trip 3, we never talked about how fast you made it to Publix and how long it took you to get back home or to your friend's house. Okay. We talked about the time for the total trip, but not for the individual legs of the trip. So we don't know exactly what time it is that you get it to Publix, but we know you make it to Publix at some point. All we know is that you return to your friend's house 18 minutes after you left your house. So you're going to turn back around this way and end up at your friend's house, because your friend's house is located at X equals 0. And you get there 18 minutes after you start. Okay? So your initial point is here for the trip 3. Your final point is down here for trip 3. And the line that connects the initial point and the final point is this line right here. Right? Make it nice and fat and bold. Very nice. Make all these lines nice and fat and bold. Okay, so you got these 3 solid pink lines. connecting your initial point and your final point for all 3 trips. I want you to remember now, go back to the previous lecture and you'll see that the velocity for the first trip, average velocity, was 29 miles per hour. It's positive, right? Meaning that you moved in the positive direction along the number line. Remember that for trip 2, your average velocity was 0. And remember, for the third trip, if you go back to your notes or go back to the previous videos, the average velocity for the third trip was negative 7.0 miles per hour. Okay. Turns out, returning to this definition here, notice that the average velocity is delta x divided by delta t. Change in x over change in t. Okay? And remember also, from your days in high school math, come back with me now to your days in high school math, and you learn that the slope of a line is equal to what? That was very impressive. I heard all of you say rise over run. Gold stars for everybody. Virtual gold stars on everybody's foreheads. Rise over run. This delta x over delta t is the rise over the run. In other words, this is not only the average velocity for trip 1, it is the slope of this line. The slope of that line is 29 miles per hour. Positive, right? It's increasing. It's got a positive slope. The slope of this line is 0. Actually, what I should do here is I should say m is 29 miles per hour. Miles over hours. Distance over time. Displacement over time. This is exactly rise over run. The slope of this line, connecting the initial and final positions, is 0, which is the average velocity. The slope and the average velocity are the same. And you guessed it, this case the slope is negative. It's going down. And so the slope of this line, if you did the math, did a conversion, you have to convert from minutes to hours, you'd find is negative 7.0 miles per hour. Again, the average is negative 7 miles per hour. The slope is negative miles per hour. So the average velocity is the slope of a line connecting the initial and final points on such a graph as this. If this was very steep like this, it'd be a very, very high positive velocity, average velocity. 0 like this, it's not going anywhere. The average velocity was 0 because it went nowhere. It started off and ended at the same location. Here, this is a slight negative velocity. But if we were going that way very fast, and we got down to the negative part of the x, if our displacement was highly negative, or if our time was very small, then our average velocity would be highly negative. It'd be very steep going down. Okay? That's how the graphing works. Okay, we'll have some questions about this on the next work, in our next work session. We'll have y'all work on some things like this then. Okay, should be fun. Should be a hoot. See you then.